Well, welcome everybody to our Cloud-Native Geo 101. I'm very excited for today because I'm as interested in this topic as anybody. I'm here to learn as much as I can. First, I want to thank our co-sponsors, CNG Cloud-Native Geo Forum and Women in GIS for sponsoring this webinar. So today we're going to be talking about basically trying to dive a little bit deeper into the technology and the meat of what is cloud native geo. What are these formats? What are the tools? And also how can these be used by GIS users? So we're trying to bridge that gap between sort of the geospatial, more cloud native groups and then GIS and how we can bring those two together. My name is Linda Stevens. I have a small little company called Spatial Spirits, and I've been working with Cloud Native Geo Forum for like 3 or 4 months, really trying to understand what their initiatives are and how we can sort of broaden that appeal. Today's presenters I'd like to introduce will be in this order. Jed Sundwall is the Executive Director of Radiant Earth, which is the overreaching organization where Cloud Native Geo Forum fits under. He has extensive experience in sort of the large big data, more in the raster side from coming from Amazon and data sharing. So his passion is really about getting data and making data available to a broader group of people. Michelle Roby is the developer advocate at Radiant, and she's our technical expert today, and she'll be giving us the deep dive into Cloud Native Geo. And then Bill Dollins is our resident GIS expert, and he'll be talking about how Cloud Native Geo is important to GIS folks, and then how you can integrate that or where and why you might want to bring that into your workflow. So with that, let me pass it over to Jed.
All right. Thanks for that, Linda. It's great to be here. And yeah, wonderful to see so many people attending. So I'm really just here to introduce sort of what we talk about when we talk about Cloud Native Geo and why we at Radiant Earth have created the Cloud Native Geo Forum. Um, I My expectation here, my understanding is a lot of people joining this call might not be very familiar with cloud native file formats or what the concept is, and so that's why this is a 101 webinar. Um, and so I'll just kick it off by explaining that we have seen over the years data volumes like across the board, not just in the geospatial realm, just getting bigger and bigger. Um, the data that we're producing and the data that we can work with is simply too large for most people to work with on a local device. Like it's just too large for you to download or store and work with it locally. So you have to work with it in what we would call like a cloud native context where data is hosted remotely and you have to interact with it remotely. What's been really awesome to see though over the past few years is how innovations in file formats and techniques for working with data have made this much, much easier and I would say much more democratized and accessible. However, as some of you may have experienced already, this has also resulted in a lot of like weird new acronyms that you might not be familiar with, or new names like Stack and Cog and GeoParquet and ZAR, things like that. We'll touch on some of those things today, but the real impetus for us to create the Cloud Native Geo Forum was to create a space where geospatial data practitioners could talk to each other about what works and what doesn't work. What we've found is that there are very few vendor neutral forums that are aimed at data practitioners. A lot of the conferences and events that get organized for our community are either focused on specific software products or are explicitly focused not on specific software products. Or are focused on specific industries, right? So like academic people convene in one place and government people convene in another place and commercial people convene in other places. What we're trying to do is create a space where everyone can get together and talk to each other about what works, what doesn't work, and then hopefully bring a lot of people on board who are sort of confused by this new world but are intrigued about it and help them just learn about what's going on and what the trends are in our community. So that's what we're here to do. Again, we've really loved working with Linda, and I just want to thanks Linda for setting this up. It's really cool to see the interest here. And over to Michelle.
Excellent. And real quick, I forgot to mention
Oh
There is
yeah.
a Q&A button on the bottom of your screen. So at the end, you can ask the panel questions. So as your questions come up, just post them in there.
Yeah. And just to go off that too, if you have a comment, please put it in the chat. The last webinar we were getting a lot of like, thanks, this is great in the Q&A, and that was just bogging down the questions. So if you have a specific question, please put it in the Q&A so we can go through those quickly at the end. And then if you're just wanting to make a comment, please put that in the chat. And this will be recorded and shared out later. And we can get those slides out too if that's something that people are wanting. So that question's already answered, so don't ask it. So I'm going to share my screen. If you were at the webinar last week, we had a more women-focused webinar last week. Can you see? It looks like yes. This I ended up adapting from the talk that Christine Schmidt gave from Intro to Cloud-Native Geo. I've given a different one more on formats in the past, or like more specifically in deep to each format, but I really loved what Christine shared last week. And so I adapted that for this. If you already saw it, it's honestly like great to see twice when hear someone else explain it too. So, and if you weren't there, then this is great for that. So just an outline of what I'll be talking about today. We're going to go over a little bit of terminology if you're new to Cloud Native Geo or Cloud Native in general. Just going to go over a few things in that way. A link of where you can get more information and detail on all of this information. Why the cloud is different. So why do we need to change the way that we're using data now than maybe a couple decades ago? How do you design a data format for the cloud? And then what data formats are already out there right now? So this is just a plug for, first the terminology. So cloud native, cloud optimized, cloud friendly. These all basically mean the same thing. So you'll hear different people use different terminology, but just as a reminder, and that's pretty much the same thing. So, yeah, also ARCO, which is analysis ready, cloud optimized, all the same. So this is the plug I mentioned earlier. We have a guide on Cloud Native Geo that was developed by Development Seed through some money from NASA for creating a guide for all the existing Cloud Native formats. So I'll talk about a few of them at the end, but if you want to do a deep dive, this is a great resource for that. We'll share this out again, but if you want more details, this is a great place to go. But kind of looking at things on a higher scale, trying to understand how the cloud is different from just working on your personal computer and having the data stored on your computer. So historically, if you were working on your computer or maybe a tower or you had a couple of servers, the compute, which is the CPU, is in your computer right there, and then right next to the storage, like physically very close together. And so in the past, the distance between where the compute's happening and where the data is has been almost like in the same place, basically. And so when they're physically right next to each other on the device, that transfer of data has been very quick. So compute and data are physically close together, means fast communication between the compute you're trying to do and the actual data. But the issue with this is our personal devices have a limited storage and they have limited compute as well. And so it's fast, but limited. And so I'll be using these icons. The ones that I'm using today are representative from AWS. So Amazon Web Service. So if you are familiar at all with AWS, their bucket, the little green bucket here, refers to their data storage service, and they call it S3. And then this little orange square is referring to their virtual machine or their E2 instance. And so we're talking, like the bigger scale of that storage and the CPU. So for the cloud, it's actually just a bunch of servers, like software just running on a bunch of servers. And they're these huge racks of servers in data warehouses somewhere. And so you see a nice little diagram in the cloud, and we're always saying like, oh, in the cloud, in the cloud. But in reality, these things exist on Earth, not up in the clouds. And there are these enormous warehouses scattered across the globe with all of those big servers. And so that's what the cloud is. And it the distance, because it's scattered all over the world and you are at home or at your office, the distance from you to that storage is quite far. And same for getting to that compute. So it means that when you're on your device and you're communicating with the virtual machine, you have to do that communication over a long distance and kind of a slow network. And then that virtual machine is then going to the cloud, going to these far away warehouses to get that data. And it's making another long, slow journey to get to that data server. So everything in this diagram is long and tedious communication in comparison to that very fast communication that happens when you're just working on one single device that's in the same room as you. But on the flip side, there are lots and lots of these servers and lots of these buckets or places where the data is being stored. And so you can scale your compute and you can work with these kinds of large data sets because you are working on multiple servers at the same time and accessing data in multiple buckets at the same time. And so that is what can speed it up. So your compute and your data are physically far apart, so that would slow it down. But there's lots of storage and lots of compute. So when you do these things in tandem, it can actually speed up the process as well. So comparing those two uses of data that we just described, when you're on your personal computer, your compute's fast because your data and your computation are close together, but there's limited storage and limited compute. Whereas on the cloud, the compute and data are physically far apart, so that slowers the communication, but you have lots of storage and lots of compute. And if you use those properly, then you can actually you can utilize that large storage and you can utilize the larger compute to your advantage. So yeah, the idea of like, how do we take advantage of the strengths of the cloud and minimize the weaknesses of that slower communication? So I'll ask the question of how to design a data format for the cloud. And the two overarching aspects that we want to look at are using addressable chunks and tiling and consolidated metadata for those chunks and tiles. And what that ends up looking like for the first one is fetching only the data that you need. If you don't need an entire scene of the entire US, you don't get the entire country. And then the second part of making metadata easy to use. So that first optimization of fetching only the data you need, this is an example of hurricane weather data. And so if you're only interested in part of the world, then you'd only get that data. And your data format needs to be in addressable chunks or tiling, so that you can get the individual chunks that you're interested in instead of the whole world in this example. And so yeah, this first optimization, fetching only the data you need, is possible by using addressable chunks and tiling in a data format. The second optimization was making metadata easy. So before you actually open a file format, you need to know where things are. So if you just look at this and you just have a file on your computer, you would know maybe the size of it, but that's kind of it. And so in order to access only the parts that you want, you need to know where that data lives. So there's two pieces of metadata information that you would need to be able to just pull out the data that you want from that first optimization. The first would be what data is in there. So knowing that we have this data somewhere in this file, and the next being where does that data live? So if we know that these chunks of data that we want are exactly in this spot, and then we can tell whatever software we're using to say, hey, I just want these things, and it can pull it out. So that second format requirement is that you need the consolidated metadata for the chunks or tiles. So the tools that you're using and the metadata can just use one request to get all the metadata. And then from there, just pick out the individual pieces that they want for computation. So as a reminder, those two format requirements are using addressable chunks and tiling, and then consolidated metadata to describe those chunks and tiling so we know where the pieces of information that we want to pull out exist so that we can do so. And this is just a little bit of a review of the things that we've already kind of talked over. So some three big things about cloud optimized, like the meaning of cloud optimized is the file formats are read oriented for support. And so we've kind of talked over these, but partial reads, parallel reads, and that file metadata in one read. And so an example I'll sometimes use with the concept of reading our data more than we're writing it. So if you're watching this on YouTube later, there's going to be we're going to write it up to the cloud once or write it onto the internet once, but people will view it over and over. And so we want this video to be set up in a way that it's easy for people to access and read in. And then people might not want to watch the whole video. Maybe they just say, oh, I want to watch that one part where Michelle talks about what cloud optimized means. They can fast forward to a point in the video, and YouTube knows that that is happening at minute like 20. And so we can read just that part of the video instead of having to be like reading it all at once. So it's less work to do so. And then parallel reads, we talked about that earlier with like all of the lines of multiple things happening at the same time. And then the file metadata in one read. So that concept of we have a small file that's all describes all the data, and so that we know where to go within a file format to get the information that we want. These are from these questions that I'll just list here. We won't go through each one, but when you're considering switching to cloud optimized data, these are from that guide that I referenced earlier. Just thinking about what questions, sorry, asking when you're generating cloud optimized geospatial data in any format, like what's important. So what variables should be included in the new data format? Will you create copies to optimize for different needs, or do you just have one need? When is the intended use case or usage profile? Will this product be used for visualization, analysis, or both? What's expected access method? How are people accessing this data? And how much of your data is typically rendered or selected at once. So these are just ideas that can help you understand how you would want to optimize your data. This diagram is showing the data types, the traditional file format, and then the cloud optimized file format for like replacement or what people would use that would be more optimized for the cloud. So for vectors, we traditionally have used shapefiles or even GeoJSON. The cloud optimized version for vector data types would be a flat GeoBuff or GeoParquet format. For point files, there's specifically for LiDAR data, class has been used in the past. There's now something called Cloud Optimized Point Cloud. That is just the cloud optimized version of this. And then for raster data, GeoTIFF has been the traditional file format. But then there's the cloud optimized GeoTIFF, or the COG, that is the GeoTIFF, but has that metadata file so that you can just read in the tiled chunks that you need. And then for data cubes, so data that's not just in the XY format, but that might also have other layers, like you might have location and time, but then you might also have things like temperature and other like land use and all these other format or data that you would want to know that goes beyond a 2 or a 3 axis of information. And so when you get into data cubes, historically there's been things like HDF5, NetCDF4, things in this realm. And the replacement for that can either be ZAR if you're creating a completely new data format, or there's a thing called kerchunk that is just the reference file, or that metadata file that we talked about earlier, being able to read that data as if it's cloud optimized. So I can get into that a little bit more here in a moment. This is just that information, but in a different table. And just reminding, and this is just the order we're going to talk these over in. So a lot of you might work with raster data. And if you are not already using cloud optimized GeoTIFFs, it's a great replacement for just using an old-fashioned GeoTIFF. A good example of a COG is Landsat on AWS is all stored in COGs, cloud optimized GeoTIFFs. And so if this diagram was a Landsat image and we only wanted the information that was in yellow, we would be able to just pull that out instead of having to download an entire Landsat scene. We could just download the small area that we're interested in and save us time, compute, and storage for being able to just read the data that we need. For vector data, a very common one is GeoParquet. Vector data is traditionally stored as rows, representing points, lines, and polygons with an attribute table, whereas GeoParquet is a columnar file format. So storing data in columns is more efficient for compression, so that you can store it compressed, and it's also more efficient for reading that data. And so GeoParquet is caught on quite a bit in the vector scene. And then doing a very brief overview, and there's more details in the guide. But it's great because it can be highly compressed and then it takes up less space when it's stored in the cloud. And there's now spatial partitioning where there used to not be. It's the last presentation I gave this that didn't exist for GeoParquet. So for the multi-dimensional raster that I mentioned earlier, so I've got this example I was alluding to where we've got latitude, longitude, time, but then we also have all these other factors like land cover, elevation, pressure, temperature, all this information we want together. And so that's when you'd probably use something like a beta cube. And ZAR is great for that. ZAR is used to represent multi-dimensional raster data. Beta cubes, like climate models, is a really good example of this. So it's chunked, compressed, and dimensional arrays, so more than 2, basically. The metadata is stored external to the data file themselves. So the data itself is often reorganized and recompressed many times, but then you can find out where things are based on that external metadata file, which is really, really helpful. Kerchunk is, I think, very cool way to use cloud optimized data. So we have these older file formats like NetCDF and HDF5. And so if you don't have the luxury of being able to reformat your entire data set, especially something like ZAR that's going to be larger, and because you have a lot of data in a multi-dimensional raster, you can use the external ZAR metadata file that lives outside the data to be able to read an archival format as if it was ZAR and use all the tools that are being formatted around ZAR for those archival file formats. So something like your chunks allows you to do that. So it removes you from needing to create and store copies of the data for cloud optimized access to be able to access the data efficiently over the cloud, which I think is really, really cool. And this is a bit of a plug for the virtual conference that we're actually holding in less than a month. It's actually 3 weeks away, since it's on a Wednesday, November 13th. We will be having one of the lead developers who's been helping with Kerchunk a lot. They have been working on something called Visualizar. Visualizar, it's kind of a tongue twister, but that is similar to Kerchunk, but a new version of it. And so that's kind of something that we wanted to mention, not as a negative warning, but just something like things are always changing in the cloud optimized world in a good way. And so new ideas and developments are always coming, but it can be a bit overwhelming if you're coming from the outside. And so the developments are good, and it's not like things are jumping too far from where things are at the moment, but just optimizing them in different ways and using, like, trying to figure out how to use the cloud the best way. So if you want to learn more about this newer version of Kerchunk, please come to our virtual conference that's in a couple weeks, and I'll have information for that at the end of this. I just wanted to put this in here quick when we were talking about these archival formats, because a lot of them do have some chunks and tiling, but the thing that they're missing is that consolidated external metadata that allows you to know where these things live so that you can access it efficiently from the cloud. So that's what you need, the two together, to be able to utilize the cloud efficiently. I'm not going to dive super deep into this, but just mentioning what I said earlier of cloud optimized point clouds is the cloud optimized version of like LiDAR measurements or LAS file. Here's that link to that Cloud-Native Geo guide again, if you're wanting to dive into all or one of these data formats more in depth and see how it can apply to the work that you're doing. And then here is the plug for the virtual conference that we'll have in 3 weeks here. It's a full day of talks and discussions around Cloud-Native Geo. The current agenda is, if you follow this link, there's a link to where the agenda is. If you want to see some of the talks that are being given. Not all of the details are out there yet, but a general idea of like who will be there and who's speaking is up there. So if you're interested, we'd love to have you to dive deeper into a lot of these technical pieces. But for now, I think these are some additional resources. So that's all, and I'll hand it off to Bill.
Thanks, Michelle. Just kind of wanted to offer a little context. I think we've seen a lot in terms of cloud-native geospatial and everything Michelle just showed, and there's more out there to learn as well. But if you're in a shop that's doing you're basically a traditional GIS practitioner, you've got your desktop GIS package, you've got, your maps to make, you've got, you're doing forestry or any of the other verticals that are traditional GIS verticals. How does this apply to you? Why should you care? And what can you do with this? So I'll offer a context from a project that I've been working for about a year now, as we've been trying to migrate one of my customers who's pretty large from a desktop GIS processing environment up into more of a cloud native approach. This is a customer that currently uses ArcGIS Pro on the desktop to do all their data processing. When we're done, ArcGIS Pro is not going away. What's going to happen, hopefully, when we're done architecting everything correctly, is that ArcGIS Pro will be making a lot of calls out to a cloud architecture to initiate the processing, and then returning relevant results back for mapping, charting, reporting, that sort of thing. So, and I think, where cloud is concerned, as Michelle showed, I think if you're a single person working with your data and your applications, probably the cloud is not for you. There's got to be a certain amount of implied scale here, whether it's the number of people or the amount of data and processing that you have to do. But, as we go forward, some of those traditional use cases, the scale is increasing rapidly. I spent many years working with federal customers. I think, between defense and intelligence and forestry and things like that, at the federal level, we know they process a lot of data. This makes sense for those kinds of use cases. But really, as we move along, more and more state and local governments are procuring LiDAR across their entire jurisdiction. It's a lot of data, local storage. It's hard to manage on local storage. They're procuring imagery for their entire jurisdiction. Same thing as resolution goes up, sizes go up. So even if your team is small, your data storage requirements are going up, your compute requirements are going up. It's getting harder to work with these large volumes of data. And that's what my current project has found, in addition to some of the other issues of just deploying, libraries of ArcPy code across hundreds of desktops, trying to keep that all in sync. Oh, you had this error because you're using the wrong version, and that sort of thing. Please update. So in this case, what we're doing is we're pulling all the processing up into the cloud, so we can have a unified processing architecture. Everybody runs the same code whenever they want to do a particular form of processing. The data is, nationwide, recollected over time. So, Michelle, I don't know if you went into Stack at all, but we're dealing Stack is an interesting protocol. It's spatiotemporal asset catalog. We're gonna lean on that pretty heavily because we have this temporal aspect. We're collecting data over the same area over periods of years, and we need to assess change. Stack is helping us do that. So this unified metadata that Michelle described, as we're processing the data to move it up into the cloud, we're pushing that off to Stack descriptors, and Stack is how we're going to find the data and pull it in to process it. So the advantage for a traditional GIS practitioner is that button that you run today, that when you set up all the parameters and you fire it off, we can do asynchronous processing in ArcGIS Pro or QGIS today. And depending on the size of the data set and the complexity of the process, it chews up your computer for a while. You can feel the case of your MacBook or your laptop starting to heat up and all that other fun stuff. We've all been there. So this basically offloads, this approach, this cloud-native approach, offloads the processing up to the cloud. So that's advantage number one. Somebody else's computer is heating up in Oregon somewhere. Mine isn't. Number two, because of the things Michelle described about like the ability for parallel reads and to only pull what you need, I don't have to load entire rasters into memory to get the piece I need. I don't need to do an intermediary step where I chunk all the data out and save it someplace and then work with a smaller set. I can directly access that cloud optimized GeoTIFF, or I can or the any of the other data I've got up there. Just pull out the piece I need and let the compute in the cloud handle it. And it actually works faster. Obviously, we can throw a lot of compute at it. It's going to work faster, but it's the optimized piece that counts, right? It's optimized because we're going and pulling out just the part of the data we need and running our process on it without a whole lot of like pre-processing. Gone are the days of my town parcels dot underscore final dot shape or intermediate dot shape or things like that. We don't need to do all that stuff. We'll just work with the data in the cloud, get the results, and then continue on with what we need to do. The other thing about optimized that's important is, it's really easy to cost yourself a lot of money on the cloud. Moving data back and forth and using more compute than you need and things like this. And this is where these formats really count. Because if you're really interested in moving to the cloud, this minimizes things like ingress and egress of data and additional compute and things like that. So like what we're doing right now with the project I'm working on, we're actually using Databricks as our primary analytical tool set. And we're using what's called a medallion architecture. So we bring data in and we process it. We leave it raw. As we receive it, we process it to standardize it. And so that the raw data is bronze. We process it into what's called silver, which means it's basically been standardized. And then gold is maybe transformed a little bit for specific application use. So we work it through that process, and we can kind of jump in at any point and get the data and work with it. Through the ArcGIS toolbox, we press a button, we do some parameters, and instead of it running on my machine, it actually forwards up through an application interface. It then uses a stack to go pull the data and then begin running a process in Databricks asynchronously. And then at the end, an event fires, it comes downstream. ArcGIS Pro knows that the data is ready, pulls the results, and I continue with my workflow. And the cloud has done all of that. So it's not running on my machine. I can do other things while that's processing. Chances are it's going to process faster. And then the real advantage is that everybody on the team, whether they're sitting in the same room, whether they're across the country, is using the same version of the application at all times, which is a huge deal. And if you're in the government, you deal a lot with managed desktop scenarios. So we had to deal with a lot that, because ArcGIS Pro was approved, and it came with ArcPy was approved. ArcPy, no knock on ArcPy, but it's not the most efficient thing to process data all the time. And in a managed desktop world, it's hard to get approval to install something like Pandas or something like that. In the cloud, we have more freedom to use those kinds of tools to optimize our analytics. So the IT folks are happy because we're not installing a bunch of additional libraries or binaries or things they need to manage, but we can actually get more advanced processing. So these are the advantages we're already seeing migrating from a traditional GIS approach into more of a cloud native. And we're not even doing half of the stuff that Michelle described today, although I've made a list of suggestions, and I have a feeling I know what our next retro is going to entail. So I think with that, I'll toss it over to Jed.
Yeah,
All right. Thank you for that, Bill. Oh, yeah. Go ahead, Linda.
No, thank you. Because I was going to just remind people we have a couple questions, but this is the time to start asking your questions. We have plenty of time. Chat for just general comments, and then put your questions in the Q&A as you're thinking through how this might affect you. So this is your chance to get your questions answered.
I like Wilfred's question. I think it's kind of a cheeky question. Like, is a computer science degree required to do cloud-native geospatial? I think it's an important question, because I think I can still imagine there are a lot of people out there that are like, whoa, like what what are we talking about? Like file formats and range requests and deploying up instances in the cloud. It can all sound really intimidating. I think the nice thing about, I think, what the community, like, and I would just want to shout out like just the geospatial data user community in general, that is just throughout my entire career has just been like so generous and open and collaborative. Is that I'll say, like, there are probably a few geniuses that are responsible for finding these approaches and designing them, who do have backgrounds in computer science. But there's also like a really a huge part of our community that's making tools that are making these things accessible and useful to you without you even knowing it, right? So like, if, for example, if you've ever used Synergize's Sentinel Hub that Planet acquired, a lot of like what makes Sentinel Hub work is cloud native technologies under the hood. So you ideally, a lot of people who don't have computer science degrees over the past, we can call it, 10 years almost, have suddenly started seeing a lot more geospatial data on the web and seeing it be really performant on the web. Like, you're in your browser interacting with huge volumes of data, and I'm sure a lot of people are just like, just take this for granted, and they just assume, oh, this is just how software works now. but under the hood, it's cloud native stuff that's happening under the hood. So if you don't have a computer science degree, that's fine. You're going to benefit from these approaches anyway. But if you want to learn, if you want to like pop the hood and see what's actually going on and how this stuff works, all these technologies are open source and they're being built collaboratively by the community. And so it's not hard to find, how to get involved. So there are many, let's see, I'm just going to go through the questions unless anyone else wants to chime in.
That's fine.
All right. The recordings of the conference will be available to anyone. We're going to put them on YouTube. There's going to be a delay for that. But yeah, our intention with Cloud Native Geo Forum is to create as much free content as possible, right? So the forum it does have a membership fee, and when we charge for our events, we need to make money to keep doing this and to make sure that we can maintain a standard of quality to produce content. But the reason we asked for contributions and for membership fees and registration fees and stuff like that is so that we can ultimately give it away for free. And so, signing up for our events is a way to subsidize access to this information by everybody in the world. And I also want to point out in response to Bart's question about the time zone issue. Right now, we're very much US focused. We're a quite small team, and just for coordination costs, most of our work we're doing tightly with people in the US, although we know we have a lot of contributors and members of our community, obviously outside of the US. Like we want to reach more people outside of these time zones. So stay tuned on that. We're starting, we just launched a Cloud Native Geo Forum like last month or something like that officially. We've been doing this work for a while, but like under this name, it's pretty new. And I'll just say stay tuned. Right now, if it looks like it's too US focused, it's because it is too US focused. We're not happy about that, but we're gonna expand more in the future. Somebody asked about a link to a GitHub repo. Where to begin? I would say the best place to start is to go to guide.cloudnativegeo.org, or if you just go to cloudnativegeo.org, there's a link to the guide in the top, like in the menu, and look around in there, and there you're going to find almost certainly many many links to GitHub repos throughout. These technologies that are cloud native have been built by people in the community, and so like Radiant Earth helped create Stack with the community, and so that's in our GitHub repo. But the GeoParquet repo is somewhere else. The GeoZar repo is somewhere else. They're all over the place. Let's see. I would say Julia Thomas asked, is there a concern about using some of the tools in the virtual environment, i.e. if it's potentially problematic on your own computer, why isn't it on the virtual environment? That's an interesting question that I don't have strong opinions about.
I think that might have been prompted by something I said. I think I can address that. In a managed it's not so much that a library or a binary is problematic. It's that there is a lot of process overhead for getting approval to install something new.
Got it.
So even if it's totally fine, which most of these tools are, it's just a lot of paperwork, and it's better to avoid that paperwork if you can.
Great. So and just if I can, I'll repeat a little bit or paraphrase just to make sure I understand what you're saying is like, if you're working on like a managed local environment where it's just impossible to install anything, it's a lot easier to spin up a virtual environment where you can experiment a little bit more freely and then just shut that down.
Yes.
Right. Okay, great.
Yeah.
Another anonymous attendee asked, will there ever be virtual development sprints? Yes, we do. Cloud Native Geo, like a huge part of our work historically has been to do virtual development sprints. That's how Stack was built, was on development sprints. A lot of them are in person. We prefer to do them in person, but we've done virtual ones before, and we'll almost certainly do it again. But yeah, development sprints are a big part of our work. Whenever we can get them funded, we like to do them. All right. Bill, I'm gonna let you answer Ruth's question about running GIS models on edge devices, if you have.
I'd love to hear this answer.
Because I don't have.
I think it's awesome because I really do think edge computing is super important in the future, but I don't know if anybody's doing it yet. Do
I
you
have
know?
some opinions on this, but I want Bill to go first.
No pressure, no pressure. So, I think in terms of edge devices, but you're probably talking like smaller devices, like phones and things like that. My
Or even
experience,
or even like devices in the field, like switches on an electrical network,
right,
like
right, right.
intelligent devices.
Yeah, so my experience in that is fairly limited. I did work at a SaaS company where we built a mobile data collection platform. And so we tended, when we had to, we would push models out to the device. We had to make sure they were small, like we were doing some computer vision models, and we just kind of had to, uh, size the models appropriately, and test them a lot. I don't know that I have a great answer for this question. It's a hard problem. You don't, if you have limits on the number of models, on the size of the model you can run. If you're in a disconnected environment and you don't have the ability to phone home, you need to account for that. So, but it was a hard problem the entire time we were trying to deal with it. So I don't know that I have a great answer for this.
Okay.
Yeah, Gregory in the comments made us. He said, I've really enjoyed DuckDB for dealing with the edge on the website, since that can compile into WebAssembly.
Yes, yeah, and I'm just getting my feet wet with DuckDB. I like what I've seen so far, especially working with columnar data formats, as Michelle mentioned earlier. Yeah, it's nice that those compressed down pretty well. It's crazy fast, like astonishingly fast. So that's been fun to play with, but I'm just getting my feet wet with it.
Yeah, there's another real quick question in the comments, and then we go back to the Q&A. It just says, is there any way we can contribute to CNG in terms of content creation and video and blogs? And CNG is a membership organization, so you can join and contribute and be part of this. There's a whole community there. So maybe, Jed, you can talk a little bit more about that.
Sure. I'll talk about that. I want to talk about the edge stuff too, but we'll come back to it. So yes, and actually I believe this is great that Krishna is saying this, because I just want to confirm that yes, Krishna messaged us on LinkedIn. So Krishna, we got your message. So thanks for chasing us down. The short answer is yes. We're going to be publicizing soon. So it's a process for this. Yes, absolutely join CNG if you can afford to. If you can't afford to, we waive fees. You can just ask and we'll waive the fee. But also, like, you don't. I mean, Linda, you're saying the right thing. Everyone should join CNG, and you should tell your friends to join too. That should be clear. But also, if you want to write content and share it with the community, we'll take it for sure. That's why we have an editorial board. We announced today we have an editorial board of people who will help us review content to see if it's fit for our blog. And so what the process is going to look like is we're going to publish guidelines for what kind of content we're looking for. If anybody wants to write it, they're going to have to lobby the board to review it and approve it. And then you'd submit a pull request to our blog, and off we go. And so that's roughly what it's going to look like, but we haven't written this down yet. And so stay tuned. But Krishna, I really appreciate it, and I want to emphasize, like, we want this to be community-led effort, when taking in contributions from the community. In the future, it's very rare that you're going to see people from within the CNG organization giving these presentations. We want people outside, from the community to be giving these presentations. On the edge thing, really quickly, I mean, I do want to emphasize the importance of trends towards things like DuckDB and WebAssembly. I can say this now that I don't work for AWS, is that you can get a ton done locally. If data is hosted in cloud optimized formats in the cloud or in an object store, you can do a lot of really interesting things at the edge. And it just keeps getting better and better as we start building the tools that allow us to work with remotely hosted data efficiently. So that's a trend that we see happening, and I think it's really exciting. Yes, it means that some of the cloud providers might not get as much compute revenue because that compute can be done locally. Um, but I also think it sort of reinforces why the cloud is just such an amazing place to share data, so they can be very broadly used. All right. We've got a question from Marta about NetCDF that I can give a very hand-wavy answer to, but I've made a point of not knowing much about NetCDF.
So the question is,
Oh yeah, sorry.
could you
Yeah.
share a bit more about data cubes in NetCDF and its integration / real-time or periodic updates, possibilities? Yeah. Okay, who wants to talk about NetCDF?
No, Bill's shaking his head too, I think. Also, I mean, my experience working with NetCDF is, well, first of all, I have like effectively none. Like I'm not a data practitioner with NetCDF. I'll just say that throughout my years of working with the meteorological community, mostly, where I've encountered a lot of NetCDF data, um, I think what Marta's asking here kind of highlights one of like the sort of the pitfalls of these traditional formats like NetCDF that are designed for archival use. They're very much designed to compile a bunch of data into a self-describing format and then be archived. Um, Not necessarily like rewritten and updated all the time. And this is where czar and things like czar come in handy. My guru on all of these things is, well, my gurus are the people in the Pangeo community. It's sort of an adjacent community to ours that had been working on improving like climate science workflows and have been pushing hard on czar as an alternative to NetCDF, I think, to solve this issue of things updating. And I have to shout out Earthmover, which is a startup started by some people from within the Pangeo community. That is their product is designed specifically to help with regularly updating multi-dimensional array data, that like NetCDF style data. So I would check them out. I'm sorry I can't give a more concrete answer. Oh boy, they keep coming in. This is great. This is great.
No,
All
isn't
right,
it?
we'll do these three. So Bart, are cloud native formats mostly used in serverless architectures in your viewpoint, or just as much in other types of architecture? Or in other words, how does CNG relate to serverless? So I would say serverless architectures are great because again, they're very sort of like ephemeral. You can spin up a tiny bit of compute, you can do a thing and then shut it down. Um, Cloud native approaches certainly enable serverless architectures quite well because the serverless thing, the function, can spin up, do a thing, knowing that there's data available to it somewhere, and then do that ephemerally and spin it back down. So I would say they're complementary. We definitely see them like uh, see a lot of overlap. And in fact, I mean, this is sort of in our name. There's another initiative called the Cloud Native Compute Foundation, which is quite a bit more, I would say precisely defined in terms of what they're doing. That is related to certainly related to what we're doing here, which is just like new compute paradigms that are enabled by the cloud. All right. And yes, Monica posted in the chat, if people can see it, a link to Pangeo, which is a great place to look. So thank you, Monica. Beatrice asked, did you get experience around transitioning from analytics on cloud infrastructure to client consumable product that requires long-term instances and private cloud or an on-premises service? Okay, so yes, I think the answer is yes. So I think Beatrice is asking, this is kind of like the sort of complementary question to Bart's question about serverless. Yes, it does make sense to use cloud native approaches if you're using long-term instances and on-premises servers as well. Because the benefits remain, which is that you can have access to very large volumes of data, you can access them efficiently as you need to. Whether or not you want to have a server that's on all the time to do that, in many cases, if you have a compute workload or compute needs or application needs that you can predict and that you can optimize for, running something on-prem on a server you can manage is maybe a really cost-effective way to do that. And so you should probably do that. And if the data that you're working with and interacting with is available in a cloud optimized way or in an efficient way, you're going to benefit from that because you won't have to copy and store all that remotely hosted data. So the use case is worth, it applies there as well. Okay, and then I think this is probably the last question we can do. How have cloud formats enabling range reads shifted data storage and structure? In the sense that there are many small files still preferred, or has there been a shift to larger single files representing entire data sets? I love this question. The answer is sweet spots. I talk about sweet spots all the time. And I need to like figure out how to draw a graph to like explain this, which is that like if you have a very large file and you want to make and it's indexed properly so that you know where you can find stuff within it, that in some cases that might be great depending on the type of data that you're dealing with and the application of the data that you're dealing with. What we're trying to balance against are different sources of latency. So if you make a request for a very large file, there's latency that comes from the request, and then there's the latency that comes from downloading and accessing that file, or that amount of content. If you've chunked up that file into a lot of tiny pieces, if you need to make, so that the transferring of a tiny piece might be quite small, but then the latency of all those requests will start piling up because each request requires time, right? So it's like, do you make one request to get a whole bunch of data, or do you make like a million requests to get a whole bunch of data? And so at some point, if you didn't get the chunk size right, it's gonna start becoming problematic. And I would say this is a space. We're all feeling our way in the dark here and figuring out like what is the right way to chunk data and figure out like the size. It's gonna, I sound like a consultant here, but it's true. Like it depends. Like it's gonna depend on your use case, how you should chunk data. And I wish I think this is maybe some research that we should probably get funded is to figure out like, is there an answer to this question? Like how has it shifted storage and structure? All I'll say is that like people are definitely chunking data more, and whether they're doing range requests within objects or exploding objects entirely the way ZAR does, where it's not a single object, but it's lots and lots of small objects. There's an ongoing debate, and conversation around this. So that's a non-answer, but I love that question.
Great. Well, that was wonderful. And we're right at the time where we need to the end of it. So thank you, everybody. I wanted to just share a slide because of the final slide, because it really is, we're at the beginning of something. And so I want to emphasize that it's up, you can get involved in helping where these things are headed, right? There's lots of ways you can contribute. We talked about content. We talked about joining the community. There's sprints. There's being part of the events that come on, giving talks, giving presentations. We'll be doing more webinars. So yeah, and then here's a list of all the folks you can follow that are here, Jed and Bill and Michelle, and we'd love to continue the conversation. And I'd like to thank again Women in GIS and CNG for sponsoring this, because I think the more we educate ourselves about where technology is going, the better we can do our work and move the industry forward. So any other closing remarks from the panels? Nope. Okay,
Thank
well,
you.
thank you.
Thanks for coming.
Yeah, thank you, everybody. We look forward to seeing you on our next sprint. Thanks.